Welcome to Audio Books feature by Cloud Expert. Today we'll be talking about Azure Load Balancer. Let's understand what is the Azure Load Balancer. Load balancing refers to evenly distributing load, incoming network traffic, across a group of backend resources or servers. Azure Load Balancer operates at Layer 4 of the Open Systems Interconnection (OSI) model. It's the single point of contact for clients. Load Balancer distributes inbound flows that arrive at the load balancer's front end to backend pool instances. These flows are according to configured load balancing rules and health probes. The backend pool instances can be Azure virtual machines or instances in a virtual machine scale set. A public load balancer can provide outbound connections for virtual machines (VMs) inside your virtual network. These connections are accomplished by translating their private IP addresses to public IP addresses. Public load balancers are used to load balance internet traffic to your VMs. An internal or private load balancer is used where private IPs are needed at the front end only. Internal load balancers are used to load balance traffic inside a virtual network. A load balancer frontend can be accessed from an on-premises network in a hybrid scenario. A load balancer provides several capabilities for both UDP and TCP applications. Let's understand the load balancing algorithm. You can create a load balancing rule to distribute traffic from the front end to a backend pool. Azure Load Balancer uses a hashing algorithm for the distribution of inbound flows, not bytes. The load balancer rewrites the headers of flows to backend pool instances. A server is available to receive new flows when a health probe indicates a healthy backend endpoint. By default, the load balancer uses a 5-tuple hash. The hash includes source IP address, source port, destination IP address, destination port, IP protocol number to map flows to available servers. Let's understand why to use Azure Load Balancer. With standard load balancer, you can scale your applications and create highly available services. The load balancer supports both inbound and outbound scenarios. A load balancer provides low latency and high throughput and scales up to millions of flows for all TCP and UDP applications. Key scenarios that you can accomplish using standard load balancer include: load balance internal and external traffic to Azure virtual machines. Increase availability by distributing resources within and across zones. Configure outbound connectivity for Azure virtual machines. Use health probes to monitor load-balanced resources. Employ port forwarding to access virtual machines in a virtual network by public IP address and port. Enable support for load balancing of IPv6. Let's understand load balancer limitations. A load balancer rule can't span two virtual networks. Frontends and their backend instances must be located in the same virtual network. A load balancer provides load balancing and port forwarding for specific TCP or UDP protocols. Load balancing rules and inbound NAT rules support TCP and UDP, but not other IP protocols including ICMP. Hope you enjoyed our audiobook about Azure Load Balancer. For more audiobooks, please visit cloudaudiobooks.in or download Cloud Expert app from Google Play Store. Hey, don't forget to rate our app and share it with your friends. Have a nice day.